And welcome back to our chemistry flipped classroom, where we are once again talking about everybody's favorite topic, stoichiometry. The nice thing is that with gases, stoichiometry is simple. So if we remember Avogadro's law says that equal volumes of gases at the same temperature and pressure contain the same number of molecules. And what that means is that those molar ratios can then give us volume ratios. So if we look at this reaction between hydrogen and oxygen to form water, we can look at this as 2 moles of hydrogen reacting with 1 mole of oxygen to form 2 moles of water. Or because we know that equal volumes contain equal numbers of molecules, we can also read this as 2 liters of hydrogen react with 1 liter of oxygen to form 2 liters of water. So those mole ratios become volume ratios. This only works if we are working from gas to gas. This does not work to replace any of the other stoichiometry that we've already learned. But if we're going from volume of one gas to volume of another gas, we can use the molar ratios as volume ratios. So what this means is that we have to balance our equation, just like we have always done for stoichiometry. And then using the balanced chemical equation, we're going to determine those mole ratios. And then because we're working with gases, we're converting from volume to volume, we can use molar ratios as volume ratios. So let's take a look at what that means. And we're going to switch to the other camera, so give me just a second. Okay, so we're going to take a look at this example problem that says what volume of oxygen gas would be needed for the complete combustion of 1.50 liters of methane. And I recognize that maybe we might not know what methane is, but we know that it's a complete combustion reaction, and we know this is oxygen, so this must be methane. So first step of any stoichiometry problem is to balance our chemical equation. So the first thing I notice is that on this side, I have 4 hydrogens, and here I have only 2. So if I put a 2 in front of the water, that fixes the hydrogen problem. But now I have 2 oxygens plus 2 oxygens. So I have 4 oxygens on the product side. So I'm going to come back over here and put a 2 in front of the oxygen. And now I have 4 oxygens on each side, 4 hydrogens on each side, and 1 carbon on each side. So my equation is balanced. So now our next step is to start with what we know. So our given is 1.50 liters of methane, CH4. Now this is where that wonderful little trick of gas stoichiometry comes in. I don't have to convert from liters to moles, because I'm asked for volume and I'm given volume. I can just use mole ratios as volume ratios. And so I can say that for every 1 liter of CH4, because that's the coefficient of the methane, I will need 2 liters of oxygen gas. And so I've canceled out liters of methane and I have liters of oxygen, and I need 3.00 liters of oxygen. So stoichiometry doesn't get a lot simpler than that. Let's do one more practice problem together. We have another combustion problem. It says what volume of carbon dioxide, so I know I'm looking for volume, would be produced by the combustion of 3.44 liters of acetylene gas, the C2H2. So again, we're given the equation, we just need to balance it. So I have 2 hydrogens and 2 hydrogens, but I have 2 carbons here, so I'm going to need to put a 2 right here. So now I can see that that isn't going to work because I have 4 oxygens plus 1 is 5. So that's not going to work with an O2 over here. So I'm going to come back and put a 2 in front of my water. That's going to give me 4 hydrogens. So that's going to require me to put a 2 in front of my acetylene, but that now requires me to put a 4 in front of the carbon dioxide. And now we have 4 hydrogens, 4 hydrogens, 4 carbons, 4 carbons, and I have 8 and 2, so I have 10 oxygens. So I'm going to put a 5 in front of the oxygen. So now I have a balanced chemical equation, and I'm going to go start my stoichiometry problem. So the given is 3.44 liters of acetylene. And again, because I'm going from volume to volume, I can just use mole ratios as volume ratios. So I know that for every 2 liters of acetylene, I'm going to produce 4 liters of carbon dioxide. And so this becomes 6.88 liters of carbon dioxide. So the easiest stoichiometry we've done all year. As always, I look forward to hearing your questions and seeing you in class.